Hi folks, this is Calc 1, Checkpoint Quiz 5. In number 1, we're given a series of limits as x is going off to infinity or negative infinity. We have to determine if they exist and if they do, what they are. So here x is going off to infinity. So we imagine x becoming a very large positive number. It becomes unbounded. So we can imagine x equaling, say, 1 billion. If I plug in x equal 1 billion to the numerator, I get 1 billion squared times 4, which is 4 billion squared, and I'm subtracting that from 3. So the result is going to be a very large negative number, large meaning large in absolute value. So the numerator is heading to negative infinity. In the denominator, if I imagine plugging in 1 billion squared, I'd have 9 billion squared minus 3 billion plus 1. And even though 3 billion is not a number to shake a stick at, the 9 billion squared is going to overwhelm that number. So we have the bottom is going to infinity as x goes to infinity. And so we get the indeterminate form minus infinity over infinity. Indeterminate means we can't determine it without doing some algebraic manipulation. So what do? The rule of thumb is we factor out the highest power of x from both the numerator and the denominator. When I factor out an x squared from these terms, it's the same as dividing each term by x squared. And I'll do the same thing in the denominator, and here the highest power of x in the denominator is also x squared. The x squareds cancel out. And so I'm left with the limit as x goes to infinity of 3 divided by x squared minus 4 divided by 9 minus 3 over x plus 1 over x squared. Now let's see if it's in the form that I can determine the limit. As x goes off to infinity, the 3 over x squared term is going to 0. Minus 4, well, the 4 is a constant. It's going to stay at 4. 9, then these guys go to 0. So I determined the limit. Yeah, the numerator is heading to 0 minus 4, which is negative 4. The denominator is heading to 9 minus 0 plus 0. That's 9. That'll do it for part A. All right, in part B, we have a limit as x is going off to negative infinity. And using the same kind of arguments we did in part A, we find that the numerator is going to negative infinity. And the denominator is going to infinity. So we have an indeterminate form, minus infinity over infinity. That means it's time to do some algebra. Let's take the limit as x goes to negative infinity. We're going to factor out the highest power of x in the numerator, which is x cubed. So dividing everything by x cubed gives me this. And in the denominator, I'm going to be factoring out an x to the 6th from inside the radical. So I'm just going to do this one step at a time, because this is where the mistakes happen on these kinds of limits. So this is where we have to be careful. I want to use properties of radicals and bring out and simplify the square root of x to the 6th. So when you think back to your intermediate algebra class, you know that the square root of x to the 6th is the square root of x cubed squared. Now the square root of anything squared is the absolute value of that thing. So what I'm getting out is the absolute value of x cubed, not x cubed necessarily. So the numerator is what it was. And now I'm simplifying the denominator and pulling out the absolute value of x cubed from the radical. So how do I simplify the absolute value of x cubed? Well, by definition, the absolute value of x cubed is one of two things. It's either x cubed itself, if x cubed is bigger than or equal to 0, or it's the opposite of x cubed, if x cubed is less than 0. So I pay attention as to where my x is heading. X is heading off to negative infinity. When I substitute negative numbers into x cubed, I'm going to get a negative number back. That means this is the formula I'm going to use as x goes to negative infinity. So this is then the limit as x goes to negative infinity of x cubed times the quantity, 6 minus 10 divided by x plus 1 divided by x cubed. And in the denominator, the absolute value of x cubed is going to be replaced with negative x cubed, or the opposite, I should say, of x cubed. Like so. Now I can get these x cubes to cancel, but I still have a negative sitting around. So this gives me the limit as x goes to negative infinity. I can put the negative wherever I want it. I guess I'll just keep it in the denominator. And I'm running out of room, I apologize, but we're pretty much done. What's the numerator heading towards? 6 minus 0 plus 0 is 6. What's the denominator heading towards? Negative square root 4 minus 0 plus 0, so that's minus square root 4. So what's my grand final answer? The limit equals 6 over negative 2, negative 3. So that'll do it for part B. Okay, part C is an interesting one. It's the limit as x goes to infinity of the cosine of 10 divided by x. So x is heading off to infinity. I imagine plugging in very large positive numbers for x, like a billion or a trillion. And the 10 over x, what's in parentheses here, that's going to 0. So as the inside of the cosine goes to 0, what's happening to the cosine? Well, cosine is a continuous function. So if the inside of cosine is going to 0, the cosine itself is going to the cosine of 0, which we know is 1. And that's it for part C.